Hi everyone, and welcome to our video on converting rectangular equations into polar equations. So in the previous video, so these are erased now, but we broke down the connection between them. When we had a polar equation or a rectangular equation, we had all sorts of formulas to look at. Let's go ahead and write them all down right here. We had x could become r cosine theta, y could become r sine theta. We did say that r is equal to plus or minus square root of x squared plus y squared. And then we had a tangent equation, tangent of theta equals y over x, which could then get theta by itself if we did an inverse tangent of the y over x. But then we still have to choose what quadrant we want this to be in. So there, because tangent would have multiple answers. Okay, so anyway, so in these problems though, all we have to do, so to convert from rectangular to polar, we just sub these ones in. We change our x and y into r cosine theta and r sine theta. So that's that first bullet. And then we'll simplify as far as we can. And then that's it. It's mostly straightforward and mostly nice. So let's see. So they're saying we should change this x right here and that y into r cosine theta and r sine theta. Okay, so our conversion would be 8 r cosine theta plus r sine theta equals 12. Okay, and I did put them in parentheses in case like things need to distribute, but we really don't need those parentheses, so I am just going to rewrite it as 8r cosine theta plus r sine theta equals 12. Well, in these problems, we try to solve for r when we can. Now, if we have multiple r's in a problem, then usually we can factor. All right, so let's factor an r out, which means we'd be left with 8 cosine of theta plus sine of theta equals 12. And then if I want r all by itself, well, I currently have r times something. That something should divide over. So the 8 cosine theta plus sine theta divides. And it looks nasty, but that's okay. Just leave everything as it is. And then that would give us our final answer for r. So r is equal to 12 divided by 8 cosine of theta plus sine of theta. And there we go. And then that's as good as it gets. Don't say, oh, that 8 and 12 should reduce. Nope. Remember, you can only reduce if you have a product. So currently we have an addition down in the denominator. So don't do any canceling because it wouldn't be accurate. And then that's it. We're all done. Okay, so that's how we can convert them. So it's a big substitution and then just kind of messing with an equation the rest of the way. So let's try number 2. So number 2, we're going to substitute our y's and x's. So again, I'm going to use parentheses. So y is r sine of theta equals 4 r cosine of theta getting squared plus 5 r cosine of theta. Okay, so all x's become r cosine theta, all y's become r sine theta. Now this squaring, there's no plus or minus, so that means the square would square the r and square the cosine function. So that means we now have, and now let's get rid of the parentheses. We would have 4 r squared is r squared, cosine squared of theta is cosine squared of theta. So remember the trig function's getting squared. So the theta is part of the trig function, so don't also square theta. It's only the cosine that's getting squared. And then still plus 5r cosine of theta. So it looks like this. Now, one thing to notice in this problem, so on this previous one, we could factor an r out, but notice in this problem, we have an r in common in every single term. So we didn't have that on the previous one. So there was a constant 12 that didn't have an r involved. So if there's an r in common in every single term, what we do is we just divide everything by r to simplify it. Because what we're doing is we're assuming that r is not 0. Because if r was 0, then that means we're dividing by 0, which would be undefined. But if r is any other number, which we'd again assume it is any other number besides 0, because if r is 0, that means our point is just right on, or our equation is just the point at the origin. So if r equals 0, that means I'm not going anywhere. And well, this is an equation that looks like we would be going somewhere. Okay, so we wouldn't be just stuck at the origin. All right, so anyway, so we're allowed to divide by r. So that's what I'm doing here. Divide by r, divide by r, divide by r. As long as all the terms have an r involved. And so now I have sine of theta equals 4r cosine squared theta plus 5 cosine of theta. And then that way, now I have a single r that I want to solve for. So let's continue solving for r. We would subtract the 5 cosine theta to both sides. Which gives us sine of theta is equal to, or not sine of theta is equal to, sine of theta minus 5 cosine of theta equal to 4r cosine squared theta. Again, I'm still just trying to solve for r. Well, currently I have nothing but multiplication over there. So I should divide by 4 and cosine squared theta to get the r all by itself. Okay, and so our final answer, now I do have r all by itself, r, would be sine of theta minus 5 cosine of theta over 4 cosine squared theta. And then that's it. Or it could be it. One thing they could do is maybe simplify this a little further by rewriting each part in that fraction. So like sine of theta over 4 cosine squared theta minus 5 cosine of theta over 4 cosine squared theta is r. So they could do that. And the reason for that is, well, they would say, well, sine over cosine in that first fraction would be a tangent. So we would have a 1/4 tangent of theta. And then they would say, well, there would have still been a cosine down below in that same fraction. So let's rewrite that as a secant theta. And then minus 5/4. And then they would say, well, cosine and cosine squared would reduce to give us a cosine of theta in the denominator. Well, a cosine of theta in the denominator could be changed to just secant of theta, like that. Okay, so this is another answer. Sorry I squeezed it in, but I just don't think it's necessary. I think the first one should be fine because it's sines and cosines is usually what we like. Okay, so that's converting rectangular to polar. So rectangular, instantly just plug in r sine theta, r cosine theta for your y and x's, and then try to get r by itself the best you can. Okay, so that's it. If you have any questions, please let me know. Otherwise, thanks for watching.